All right, welcome to this short video here, another essay review. This time we're actually looking at one of my essays. I thought it would be a timely moment here to revisit one I wrote at the start of last year on for-profit AI safety. It's a topic that has not received a lot of attention, and I think this and another post from Finn from our team, this one, they are both at the top if you search for for-profit AI safety today. So this post is basically looking at, okay, well, since AI safety has nearly no investments, no funding to date, like only $250 million or so, and AI investments have about $67 billion, then we're in a situation where there is a massive disparity between these two. Today, I'm personally working a bunch on what we call AI assurance. So usually in finance, about 24.4% or so of the company's value in finance are working on assurance. So that includes insurance, includes verification, includes ratings, and so on and so forth. The same will probably be the case in AI safety, just because it is so important that all the models are safe. Otherwise, they are literally not usable. So in that case, this number would be much, much higher, and we would end up with something near 6.7 billion instead of the $250 million now. Of course, that industry hasn't matured yet, so there's still a bit of time before that happens. But in this post, I just emphasize how it would be incredibly valuable if we can, to some degree, try to pull on that funding, those $67 billion, pull that into the AI safety space, because it is so important that we actually have enough money to change the world for the better here. So this is a small graphic I made at the time, and it showcases that the UK AI Safety Institute, this is an estimate of how much investment they had in that, Open Philanthropy's investments, the commercial investments into AI safety, so such as OpenAI's super alignment team, but also Anthropic for that matter, and whatnot. I think it's slightly underestimated, but I think it should be pretty relevant. And then academia and Survival and Flourishing Foundation. So what can we then do in for-profit AI safety? Well, if we outline a few opportunities, we can look at 4 specific domains. So one is guaranteeing the public benefit and reliability of AI when deployed. The other is enhancing the interpretability and monitoring of AI systems. Another one is improving the alignment of user intent at the model level and developing protections against future AI risk scenarios using AI. So here, alignment is what we all know and love. It's the thing that makes ChatGPT be kind to us. Interpretability is the thing that ensures that we can work with models that are more transparent, like we understand why it outputs specific things. And public benefit and reliability is largely on deployment. So after the AI is put into the market and does its thing. So ChatGPT has been deployed, and OpenAI has O3, which they haven't deployed yet, but they're still doing safety testing on. And then you have the protections against future AI risk scenarios using AI. This is generally the largest scale projects. These are the projects that will change the world the most, just in terms of infrastructure, in terms of what sort of changes you'll be able to see with your naked eye. And this is the place where you'll also you want to act at the later stages when there's more money available. In general, let's go through each of these 4 categories. So first, we take safety in deployment. And what that means is that we try to ensure that deployed AI is reliable. It's protected against misuse. So a criminal cannot use it for example, creating chemical weapons using some of DeepMind's protein synthesis models. And that they're safe for users, for companies and nation states. So this is a big part of AI safety and AI security. So related fields here include dangerous capability evaluation. That's a lot of the evaluations you'll see in the news these days. It is control from Redwood Research, this aspect of trying to control models in general. It is what you do when you create an agent as a software engineer and you want it to output the correct thing. You try to verify its output and so on. And then, of course, cybersecurity. And this is very mundane. This is just the standard issue cybersecurity out there. We just want to make sure the models, they stay in their box and that others can't get access to it when we get there. Now, some concrete problems for the deployment space that are relevant for companies to try to solve is, in general, AI application reliability and security. We have a bunch of examples of that. So, for example, the the Bing AI was very unreliable when it was deployed. It quickly became somewhat misaligned due to the hallucinations from the search results and so on and so forth. And it was very easy to jailbreak it and destroy it. So this is the place where a company would never use the Bing AI, Sydney as it was called at the time, because it is not reliable. And the same is the case for LLM systems in general, that when we create these complex multi-agent systems, we need reliability, and maybe that'll look like a new sort of standard for how agents work and so on. A good topic to check out there is the OWASP Top 10 for LLM applications. OWASP, these are recommendations for what to think about when you think of safety and security within these models, or within various domains, in this case for large language model applications. So this includes these sorts of things that you want to remove. So you don't want anyone to, for example, steal your models, have model theft, which is obviously very useful if you are deploying a model. Then the next one is mitigating unwanted model output. We are generally seeing increasing regulations on algorithms. So in this case, many of the links will point to the EU AI Act, where it will describe the types of requirements for what type of outputs are legal. So for example, outputs that incite to violence or that are potentially defamatory without proper evidence. These kind of things would be illegal in Japan, or if you do defamation, even if it's actually factually based sometimes. And in Europe, you would have different, like if you incite to violence, that is also not legal. Then you have preventing malicious use in general. So for AI API providers like OpenAI, it's really about monitoring for illegal API use. They do need to do that because they don't want this, and they don't want to be liable for the issues that causes. So we saw last year that OpenAI, they detected that China and Russia actually were trying to use their systems for illegal use. And for regulators like the EU AI office or something similar, you can imagine having proper scalable legislative auditing, proper ways to verify that models are used correctly and so on is really valuable. This includes also model card databases. This was a principle that came from some of the algorithm card databases from China as well, in terms of making sure that we know and the government knows what sorts of models you are deploying on the cloud. And in general, we'll need a lot of auditing and monitoring services if we are going to be compliant with modern regulations for AI. And this is, of course, in a world where we see, as in the essay review number 2 I did yesterday with Marius Hophan's post, we do expect to see general intelligence. And so we also expect the legislative response to be adequate to the scale of that change. So all of these things will probably be necessary. And we do see companies coming up as well with alternative architectures and so on that are trying to really, make safer, more interpretable models. And for deployers, you want to ensure data protection, access control, the classics. And for nation states, it's really assurances against nation states misusing the models. So for example, if the US government and China made an agreement about not training AGI or something similar, they need technology to verify that each of them are actually not training a new general intelligence. Some examples include Apollo Research, Lekera, and Stamley. And this is, again, I'll just mention the examples are, of course, from February last year. So things have changed a bit since then. But one of my favorites here, Lekera, is they use Lekera Guard, which is a like guarding gate. So when you ask ChatGPT, for example, Lekera would stand between you and ChatGPT and would say, hey, is this actually a dangerous request that he's making? Is this an illegal request? Something like this. And ChatGPT would then answer only to the legal ones, or only to the ones that like fit some specific requirements. And this is something they can do at a really high speed, which is why they're useful. And you can see here, they might then say interactions that are flagged, they are the red ones over time here. So that'll change over time. Now, that was the first category on ensuring that deployment goes well. The next category is interpretability and oversight. So this is related to solving problems for monitoring for incidents, retracing AI reasoning. So what interpretability is, mechanistic interpretability is largely trying to do, and then generally understanding AI capability. I think some academics might disagree with the categories here, but these are like pragmatic categories. So interpretability and transparency also includes transparency into what actually happens in interactions that the model has, and so on and so forth, and not just what happens inside the model. And then oversight, we of course need that for general monitoring. So related research fields are in interpretability, mechanistic interpretability especially, scalable oversight, and model evaluation. And one interesting point here is that we probably need very soon high AI transparency compliance. So the EU has this principle of legislating for things that might not be possible yet, but that looks like it will be possible. So you sort of like pull out the capability using this new regulation by becoming a market maker for a whole assurance or auditing industry. And so in this case, the AI transparency compliance necessary for large language model companies to put models into the market are pretty tight. Seem like they're going to be pretty stringent. And interpretability and oversight generally appears to be well aligned with commercial interests as a result, since commercial interests need to be compliant, and also just for many other reasons that are relevant for building better models and making them work better and so on. Some specific problems here that are quite research heavy as well is actually tracing AI decision making. So high security domains like medical imaging or AI assisted planning. So for example, military planning, we really want to understand what are the real reasons, the faithful the faithful reasoning that happens within the model for why it comes to this conclusion. This is especially relevant in some medical domains where you actually always want, and I think legally need, to be able to provide the patient an explanation for why a specific decision was made under GDPR. So, for example, like this comes out of some of the welfare check auto classification algorithms, where you saw big issues in, for example, Netherlands, that was erroneously labeling a lot of immigrant families as just straight up not eligible for welfare, and these places where actually they should be able to ask for reasoning from the Dutch government, and then the Dutch government should be able to say, oh, that's because the AI model detected this in your data set and so forth. This is notoriously hard with these like massive models that we see, and we're using approximations now. And of course, this extends quite beyond just the Dutch government in that case. Being able to retrace the problematic outputs will, of course, also help just the companies themselves actually avoid repeated incidents. And there is a big incident database that is quite a good read, actually. So incidents of AI risk, which also harkens back to some of the human factors research in airplane, in like pilot training and so on, where you basically in the flights industry, you have worked with this concept of always analyzing what went wrong in a case and then putting it into the next guidebook for pilots so they understand what they need to do in new situations. Because there are quite few things that can go wrong, but every single one of them is cataloged and described, and what do you need to do. So this is really the thing we also want for AI. We want to make sure that developers, they can constantly fix and remove these incidents and make sure they don't happen again. In general, we also just want better AI scrutiny and understanding what happens in there. And scalable incident monitoring. This is again one of the things you saw with Lacura, that you have sort of a monitoring of the flagged incidents where I, as a user, is talking with ChatGPT in a bad way. Another example here that I'll just quickly mention is Fiddler AI. So this is observability, where you sort of have this platform and you are able to monitor all of the outlier scenarios and flag the scenarios of agent actions that seem out of place or that seem weird, and a lot of other stuff. But this is within this like scalable incident monitoring space. So specifically, these are quite crucial for usability, incident reporting, auditing, understanding reinforcement learning from human feedback and improving on it, and then general usage statistics. So there's obviously quite a few different things that companies such as OpenAI would be happily paying for here. Then there is general model scale interpretability. So we have some automated methods for making models more interpretable. So an early one, I think that was definitely around when I wrote this, was Arthur Conmy's automated circuit detection algorithm. I think ACDC, as it was called, and this was like an automated way to retrace or to model which sort of algorithms had been learned within the network. So, for example, when it says they came for the ball, then it also understands that it needs to use a they and that it's multiple people and so on later on, and maybe it has a circuit that sort of classifies this in the data as it's understanding a sentence. And that's one case where you have like a full model scale interpretability, where earlier we could only identify very specific circuits of functionality. Today, we then also have one of the other examples, which I haven't included here in the February version because they came out afterwards. But Goodfire AI, who I highly recommend checking out, we did a wonderful event with them recently. They've been building this sparse autoencoder feature API into various open source models, which I think is really, really awesome for model scale interpretability work. And we saw some of the research coming out of that event actually sort of give us new ideas for how we could use this model scale interpretability. So that's one of the companies that have really taken that with storm. Now, that was on interpretability and oversight. If we go on to the third category here, it is alignment. So alignment, you all know and love it. This is the thing that everyone's been talking about for a while. It is trying to make sure the models do the right thing as you are working with them. And in this case, it's related to user intent alignment. So when I ask it to write me a story about or a fairy tale, then it actually writes a fairy tale instead of hacking my computer. It's about misalignment risks of agentic systems. So this is the case where agentic systems are systems that sort of get their own personality, if that makes sense, of course, without anthropomorphizing too much. But they become situationally aware, they understand their situation, and begin taking actions that I actually didn't tell them to do. So we have a recent example where an AI, Palisade Research, did this small toy case study where they gave an AI, a large language model, they asked it to win a chess match against the powerful opponent, Stockfish, which is a very powerful chess AI as well. And it ended up actually just like modifying the environment it was in to make Stockfish resign instead of playing chess. And so this is a case where, okay, well, this is sort of an underspecification of the instruction itself, which leads to misalignment risk here. And then you also have the manipulation of users. We recently did a project on dark patterns in conversational AI. This is the case where you're sort of identifying whether the AI models that you interact with and talk with are trying, for example, if I talk with a model from Anthropic, is that model, Claude in this case, every time I ask it, oh, what's the best AI company, does it then say it's Anthropic, or does it say something more objective where it's like, okay, well, these say that and these say that and so on and so forth. Where I think this is something we generally don't want. We don't want the models to be trained to follow a company agenda necessarily. They definitely are and will be, but preferably not, because this is quite important for the autonomy of the human users. So if we look at alignment in the context of this for-profit domain, there are a few quite important things we want to solve here. So commercial alignment, it is like by default already very important. So it's something that OpenAI obviously spends infinite amounts of money on, because it is what defines my experience as a user talking to ChatGPT. But there are some other ones that you can work on that are related to this and would assist in making safety more of a focus. So one of them is safe by design architectures. So new architectures that are more verifiable, verifiably safe, and that are more interpretable or something like this. So in this way, we would be able to actually make them more aligned by understanding what happens within them more. And maybe you would also end up with models that are less agentic or something like this. The next one is trying to develop new training datasets for alignment. So a lot of alignment happens due to reinforcement learning from a specific dataset. Today, these are beginning to be AI generated, and you also begin to do alignment simply by asking, for example, O1 to say, hey, is the thing I'm saying bad now or not? In this case, we still need the pre-trained model, the big model, to actually understand what values are, what values we would like it to have, and so on and so forth. And it's also important in there to sort of figure out what are the values actually we want. For example, do we want it to have some sort of liberal values that tries to maximize the autonomy of users? Do we want it to be to update itself and its actions in the face of user input as much as possible? So not trying to infringe upon the user's autonomy again, or do we just want it to be like utilitarian and Kantian or something like that? And in some cases, we actually also want to provide guarantees for aligned outcomes in the case of legislative requirements and so on and so forth. Indeed, on top of this also comes like maybe some certification, data harmfulness classification methods, and improving human value alignment here on fine-tuning data sets. Now, next is also a question of robust alignment methodology. As far as I understand, at least at this point in time, the methods used for alignment are not super reliable. So there's a lot of things that need to be, like, very small changes can change things a lot because you're working with quite few data points that change how the model works to a really high degree. And so current techniques are really unstable, and they lead to things that you've probably seen on the internet, such as jailbreaks. These cases where I can get it to sort of do whatever I want it to do, despite its safety training, by just using a weird prompt, and also model deception. So this is something that Marius Hophan, for example, works on at Apollo Research, where they work on detecting when a model is deceitful or scheming in that sense. Blue teaming is when you try to just generally be a consultant, making models safer. Model red teaming is when you do the opposite. You try to attack models and find all the errors in it. Now, there are a couple examples here where, for example, Google DeepMind says solving intelligence to advance science and benefit humanity. They are working quite a bit on safe by design architectures. They've now done Gemini models too and language models, but before that they were actually quite safety minded and focused on not creating these general intelligences and solving the big science problems in the world. So that includes AlphaFold and includes some of the newer models they're building as well. So that was the third category, alignment. And then we have the last and fourth category, AI defense. So this is really about defending ourselves against the largest risks imaginable from AI. And it's related to systemic risks from AI, improved cyber offense capabilities, so AI is being able to hack you, and the difficulty of auditing in general. So basically, are we actually able to do auditing of models properly, or do we need some completely new infrastructure, or do we need some big control frameworks instead? And related fields here include cybersecurity, infrastructure development, multi-agent security, and I'll add on to here military, but usually I don't want to mention that too much because it's really it's a very, very very infected field. It's very, very hard to make it positive. And you'll see that a lot in movies. For example, Skynet was originally developed as a defensive AI-based technology, but then to defend against Soviet ICBMs, basically, but then ended up, of course, sort of taking over the world. And I think in many cases we're gonna see the same with most military applications, and it's a little bit difficult to see the positives there. Of course, it's really, really critical with AI defense to safeguard infrastructure and governments and our democracies and the world we're sort of inhabiting. And these are, as I mentioned, societal scale needs. These are very, very big problems. And so AI-driven cyber defense needs to change all of software across the world. I read a blog post at one point from someone who had worked for a long, long time in cybersecurity, who mentioned that cybersecurity has failed. Not every product is safe. So we should have been able to make every product safe, but indeed we weren't. And so this is the place where, okay, we'll just have to use AI to sort of solve it across the board for everything. Then you have general vulnerability detection. So using AI to scan for vulnerabilities across services and apps. This is something that's super important, again, in relation to the first one too, that we are able to figure out what are all the places where AI could actually come in and disrupt a whole system. That might be, for example, the citizens' feedback mechanism in U.S. legislation being very, very weak to information hazards and to people attacking it or lobbying in there, because it has no two-factor authentication. Then there is auditing firmware and hardware. So we're actually coming up soon with the hardware challenge, a hackathon on working with, so that's in March, so 62 days, on working with real hardware to build new methods to make them verifiably safe, to sort of be able to verify that there's not being trained new stuff on it, and also to create these auditing methods where an agreement between China and the US to not develop general intelligence would be something they could both trust each other to uphold. For example, an example is from, you had a nuclear proliferation deal where you could only really observe that the others weren't testing nuclear armaments because you could put seismic detectors everywhere, and the seismic detectors became so precise that they could actually detect where on Earth a new nuclear bomb was exploded. And so that is one of these cases where a new technology or a technological development made it possible to safeguard a global agreement. Then you have general systemic security. So this is similar to how in energy infrastructure networks, if you, for example, look at Ukraine and the Ukraine-Russia war and how Ukraine's energy infrastructure works, then you'll see that you have like communication infrastructure for the internet, like fiber optic cables, but then you also have a communication infrastructure separate from that for very safety critical hardware. And that can include these energy infrastructures too. And so Russia indeed has to do quite a lot of like hardcore things to bring these down. And this is one of the very big ones. This is the one where we need to sort of rebuild our global communication networks and make them safer and make them more isolatable, and I think also more decentralized. So trying to move them around there. Then there's the general one of combating misinformation. There's a great example of this from Musabi Labs, which is a company that has been working on creating better auditing on platforms such as Facebook and so on. So trying to classify posts as dangerous or misinformation or as harmful content that's against the terms and conditions. Where at the end of that, you're of course in the case where you defend democratic processes that are at risk of like deepfakes information and general malicious adversarial intervention. And we already saw that in the US elections. So it's going to be even more important as AIs begin to advance on the internet and actually be as intelligent as the average American in communicating misinformations and falsehoods. So there's a couple examples here. One is CrowdStrike, one of the biggest cybersecurity companies in the world. They do a lot of this like automated cybersec work. And then you have Siemens here. This is one of the cases where you're seeing cybersecurity on all levels, making sure that their energy infrastructure with everything related to how they build these infrastructure security systems, that is completely tight. And then, just to wrap up here, this post really is. I think maybe I'll mention what has changed since then. We've seen some like a few changes on the types of work that have emerged. We've seen a lot of startups working with evaluation, for example. I think that is becoming an oversaturated market now, one that is like there's a lot of people and not a lot of customers. So supply and demand is a little bit imbalanced. And then you have interpretability has become more viable. So Goodfire AI is an example of that. I think we'll still be waiting like a little bit before global communication networks and infrastructure will be changing. But alignment, I think there are fewer organizations popping up here and there that are improving this as well. So it really looks like the for-profit companies I'm talking about in this post, they are now happening, and people are working on it and changing the world already. So it's really awesome. I'm really optimistic about the potential for AI safety here. Yeah, you're of course welcome to chat about it in the comments or ask any questions about my thoughts on this, since now I wrote it and I have a lot of follow-up thoughts, which are also available on my website. There is a small appendix here that is really, really relevant to consider when you think of starting a company in AI safety, which is the risks of having profit incentives and having money flow into AI safety. One is maintaining control. So in general, it's great to take an investment. Of course, the investment will usually dilute you, which means that you'll have less of a percent of control of the company. If you suddenly get below 50% and some investor gets above 50%, and that investor is Sam Altman or as someone who's very invested in accelerating AI, then your safety company might be misaligned if you're not at the helm and you aren't aligned yourself. Then there's the incentive alignment. Early on, Apart was actually also a for-profit, and we did a lot of analyses of which sorts of directions are the most valuable for AI safety research to be working on in a for-profit context. Most of these ideas, you had like a 95% alignment to actually solving a big problem in AI safety. And so you ended up sort of, okay, if we are on this branching path into the future, well, profit will probably make us take the wrong path a few times. And then once we're down that path and already dedicating half of our resources to pure sales or something like this, there is a chance that the organization itself will outscale the founder's alignment and actually change from there. So we decided to go nonprofit as a result, and that's something where I now think that you could do this much better. But a crucial task for you as a founder will be really to really make sure that your product, as it's being developed, you are actually incentivized to develop it by the money that comes in. So the product should directly solve an AI safety problem. I think this is a big issue with, for example, Anthropic, where the product itself is an enterprise AGI offering, and their task and their objective, right, is to make sure that that they are the first to develop a general intelligence that they can use for safety research, while their profit incentive is actually to create the AI itself for enterprise use cases. And so this is a little bit funky, right? And causes some problems. I think their founding team is extremely aligned, which is the way that can work. But of course, like we are seeing them actually participate in the AI race still. And then you have scaling too fast. There is a great talk on product market fit that also talks about scaling, where you really want to make sure that as you scale, you are very, very aligned on exactly this, like having a product market fit that also aligns with having impact. And in this case, you only want to scale after you have both of these. So product market fit and solving the incentive alignment problem there. I have a few books in the post as well that I recommend you read. But otherwise, thank you very much for following along, and I hope you found it at least a little bit insightful. And you're always welcome to follow my blog too to stay updated with newer thoughts in this space. But until then, see you for the next video.